Okay, I want to back up here a second and just talk to you guys about something that you should have noticed it's kind of in common about these fossils. You notice that this bird was buried rapidly by a volcanic ash deposit, kind of killed in life position. It was probably flying along and was just knocked down by the fallout from a volcanic eruption, preserved as buried in the sediment in the lake. Same thing with those mud cracks and those dinosaur tracks. In order to be preserved, they had to form and then be buried very quickly. Otherwise, they too would be eroded and washed away. So one thing that you're going to notice about all fossils is that a fossil usually it will not form unless it's rapidly buried and protected. And this is why they also tend to be so well preserved, because once they're buried and locked away underneath the sediment and in the rock, nothing's going to disturb it until it's discovered. So this should help you understand that although we find many, many fossils, becoming a fossil is really hard. It's like trying to win a lottery. Because if you think about it, if there were dinosaurs crossing the roads and the streets, let's say small dinosaurs that crossed our roads and streets like the deer, and then they got hit by cars and they were on the side of the road, are they going to become a fossil? Not likely, because, you know, scavengers are going to come along and pick at them, and you're going to get it'll rot, it'll decay, it'll fall apart, it'll be weathered just like the stones. It get worn out by the environment and just kind of fall apart and be consumed by bacteria and fungi and things like that because it's exposed. So in every case, to become a fossil, something special has to happen. It'd be like if you were hiking along a trail in the mountains, and if people slid off that mountain normally, and they were found at the bottom. Let's say they passed away from the fall, but they were discovered at the bottom of the hill. Um, all kinds of bad things could happen to them in the meantime, right? They could become a meal, but they're not going to become a fossil. But if you triggered a landslide at the same time as you were walking that trail and got buried, yeah, you died, but your remains are protected. They're cut off from scavengers, and if it's buried in a thick enough sediment, it's cut off from the air and cut off from the microbes that are going to decompose it. And that's when a fossil can form. So if you look at this T-Rex here, it's a very, very complete skeleton. This is Sue, the most complete T-Rex ever found. And this is when they're digging it out right here. For Sue to be preserved like this, she had to have been buried very quickly. And these scientists that are excavating her have studied the sediments as well. And the sediments are a landslide deposit. So Sue was quite possibly triggered her own landslide. When this thing hits take a step, it could shake the ground. But something catastrophic like a landslide buried Sue and preserved her. Okay, just remember that fossils require rapid burial. All right, and that's true of some other life that came after the dinosaurs, except in many cases it was rapid freezing as well as burial. Um, the we find woolly mammoths with the meat still on them, 10,000-year-old mammoth meat. In fact, there are stories of like fur trappers that had teams of dogs for their sleds. If they found one of these mammoths thawing out of the riverbank and it was still had meat on it, their dogs would eat it. They'd feed it to their dogs. Um, so these are still original remains. They're not petrified. They're bone, real bone. Unlike dinosaurs, dinosaurs are petrified. This turns to stone. It's just like petrified wood. But these are real bone and real flesh, real, very close to home. Um, in fact, sometimes close to home, really. Like this is the Brea Tar Pits in Los Angeles, and this tar pit in here, which has been in several Hollywood movies, is right in the heart of Los Angeles. And they find in here it's a tar pit. The earthquake faults that run through Los Angeles intersect deep in the earth here and cut into a tar deposit, a petroleum deposit. It's sort of a thick, sticky oil, and as it surfaces here, these animals would go in and get stuck in it. And once they got stuck in it, they couldn't get out. And what's really kind of interesting is that you see a lot of these saber-toothed cats also here. And it's very interesting the story behind them. Almost all of the saber-toothed cats that are found in here have something wrong with them. They have like problems where their backs were broken and they didn't heal properly, or like shoulders that were broken, hips that were broken, and a story starts to emerge. This is where geology and paleontology is like crime scene investigator. These are animals that hunted by ambush, and they hunted prey that were much bigger than they are, and so they would leap on to like a giant sloth or even a woolly mammoth and then try to cut their throat and their arteries with these long teeth. But if they failed and one of these big animals was able to crush them against a wall or step on them, they could get broken bones that then make them ineffective hunters. And so what are they going to be looking for? An easy meal. And the easy meal is one that's trapped in the tar. But what happens as a result of that? They get trapped too. So there are hundreds of these saber-toothed cats fossilized in here as well. It's like a giant sticky trap that's collecting all these ancient life forms. All right, and here in Virginia and along the coast of Maryland, a place called Calvert Cliffs. These cliffs are Miocene, and we used to have the Meg. You've seen the movie or you've heard of it, the Meg with Jason Statham, and this is the megalodon. This is how many, these are full-life people, size people inside the mouth, and this is the size of the teeth. And you can find them popping out of this cliff here as it erodes from the wave action. We used to have a lot of these guys cruising up and down the coast of the East Coast here, feeding on large mammals like whales. Not a real picture, but it shows you how big they were. If you were to try to catch one, this is what you'd be looking at. It's been enhanced, obviously. All right, now weathering. We've talked about this. You guys did a whole assignment on this, so I'm not going to really spend a lot of time on it. But remember, there's two types of weathering. There's physical weathering, which is just the physical breaking up of the rocks. But once you break up the rocks, you then make it easier to chemically weather it. And I can tell you what, one of the easiest examples you can try, go home and get some of that coarse grained like turbinado sugar, put it in your mouth and try to dissolve it. Then do the same thing with powdered sugar, like confectioner sugar you put on those like white powdery donuts, and taste that and ask yourself which one is sweeter. The answer is they're both the same, but the sugar, the powdered sugar, will taste sweeter to you because when you break up the particles and make them smaller, there are more reaction sites, so you're dissolving the sugar more rapidly, so you get a more intense burst of sweetness. Does that make sense? All right, so the physical weathering helps the chemical weathering occur faster. So we talked about this, about how the acid dissolves the rock and creates this. All right, more chemical weathering. I'm not going to go into all the details on this. Some of this is just too into the nitty-gritty weeds, but I do want to mention that when you have a granite like this and you dissolve it, the quartz is not going to dissolve. Quartz is incredibly resistant to weathering. It's the reason that it's on all the deserts and the beaches in the world. You can break it up and make it smaller, but you can't dissolve it, not easily, and so it stays. But things like feldspar and mica and biotite, those are the dark things in the rock, and the pink in the rock, they turn into clay. So pretty much everything gets turned into clay, and then all that's left is the sand made of quartz. Make sense? And then it gets washed in the rivers down to the beach. All right, and there's whenever you talk about erosion, it's transportation. Remember that. Weathering is the breaking down and the disintegration of the rock, kind of like rotting the rock. And erosion is the transport, and you can do that with wind, rain, water, ice like glaciers, and gravity. Of course, gravity makes things fall and transports them too. All right, and we'll move on. Okay, deposition. Okay, this picture's good. Look at the mountains in the background, and there's big jagged rocks out there. But what happens to the size of the rocks, or the boulders? What happens to the size of the boulders as they get rolled and tumbled and banged against each other as they move their way down the river and make their way towards the ocean? the boulders get smaller into cobbles and into gravel, into sand, and then silt in the water, and then clay. Some of you have had an experience with this. You may have noticed that when you go to the beach or go to a lake, there might be like some sand and gravel on the shore, but as you get out deeper into the water, all of a sudden it's kind of nasty and gooey and squishy, and you start to feel the mud between your toes. It's because the mud doesn't settle out until you get deeper out into the water, where the sand and the gravel and silt, they will settle out closer to the shore. If you want to think of this as another simpler analogy, imagine yourself going down this water slide, and you're going down the water slide quickly. What happens when you hit the swimming pool? Do you slide across the pool and hit the other side? No, you pretty much stop as soon as you hit the water, right? And in fact, you better get out of the way because you're going to get hit by the next guy. All right? So think of the rocks and the sediments as the same. The big heavy sediments, they're going to go down this water slide too, called a river, and they're going to hit the ocean, and they're going to settle out in that water in the near shore, and that's why we get sandbars and sand on the beach. But if you keep going out into the ocean, you'll eventually get to the mud and the silt. Okay? And there we go. That's it. That's the whole story. So there's our rock cycle, and we'll touch on metamorphic rocks when I'm back. So if you have any questions for me, you can well, we'll touch base. See ya.